Okay, this is a redo video for those of you who are not able to see the show me video on integer operations. So integer operations should be in your notebook under FDP conversions, which is your Dr. Pepper foldable. And your integer operations are going to be on pages 8 through 11. So even though we haven't done everything for integer operations yet, just make sure you put your page numbers as 8 through 11. Okay, so now let's go ahead and flip over to page 8. And it should be right behind when we did notes in class. We did mixed numbers and improper fractions. And then you're to put your FDP foldable in your notebook, pages 6 and 7. So on page 8, we're going to have adding and subtracting fractions. So make sure you number your page and start writing. Okay, for adding integers, we have two different rules. We have a same signs rule and we have a different signs rule. So if your signs are the same, that means both numbers are positive or both numbers are negative. If the signs are different, then that means one is positive and the other is negative. Okay, so if the signs are same, we're going to add the numbers and keep the sign. If they're different, we're going to subtract the numbers and keep the sign of the larger absolute value. So the key thing to know is if it's the same, you add, different, you subtract. And I would even think of same, adding gives you a sum. So you got two S's right there. For different signs, you're going to find a difference. So, I mean, they pretty much kind of go along together. Okay, I'm going to model what this concept is like. So, let's do the -3 plus the -5. So if I put it on the red side of my little candies, then that means I'm showing my negative. So it says that I need 3 negatives and then another 5 negatives. Excuse me. Well, since they're all the same, everything you see here is red, then that's why I'm going to add it all together. I mean, I can add all these together and I still have all reds. And what I have now is 8 reds. So that's how I have 8 negatives. So that's the basic concept. Okay, let's model this one right here, the -4 plus 8. So that means I will have 4 negatives. So 4 candies on the red side. And then I need 8 positives. So 8 candies on the green side. Okay, so what I'm doing basically is I'm going to pair up positives and negatives to make 0 pairs. So a positive and a negative makes a 0 pair, which means they cancel each other out. So I see that I can pair up these two. They cancel out. I can take these two, pair them up, cancel out. I can take these two, they pair up, cancel out. And then if I take these two and pair up and cancel out. Now I have no more negatives over here, so all that's left is these 4 positives. So that's how I end up with the +4. So it's basically following the rule that if your signs are the same, you can add it all together. Because if I have some negatives and I put more negatives in my hand, well, everything is still negative. I'm just adding on to it. If I have some negatives and I put some positives in it, I can't say, well, now I've got all negatives or all positives in my hand because I have different stuff. So all I can do is say I've got more of one than I have of the other. And that's pretty much what your answer is telling you. So for this one, since we're doing subtracting, it's just saying that I have 4 more positives than I have negatives. When I look at this example, when I look at this example right here, I can easily see that this is a 12, this is a 5. So we can tell that there's more negatives than there are positives, which means my answer will be negative. And since there are 7 more negatives, my answer is a -7. Okay, now when we go to subtracting integers, we're going to use add the opposite or addition of the opposite. Same thing. And all this means is that we're going to change our problem to an addition problem first. Once we do that, then we're going to go right back and follow these rules that we used up here. So we're really still applying the same addition rules. We just have to change it to an addition problem first. And we use a little mnemonic device called keep, change, change to help us remember what to do to each number as we go through it. So let's look at our examples very quickly. The first one, we have 5 minus 9. Now, common sense should tell you that 5 minus 9 is not going to give you a positive answer, because I can't start with 5 and take away 9 and actually have 9 to give. I'm still going to owe some more. All I have is 5 to give. I'm still owe 4. So that's telling you right there you're going to have a negative answer. So the first thing we're going to do is I tend to split my numbers up. So I put a line behind the first number. I put the minus sign in the middle. And then the last number should be sitting behind the line. So when I apply my keep, change, change, I'm going to keep the 5. I'm going to change minus to plus. And this 9 back here is going to become a negative 9. Now I can easily see that these are different signs. So I subtract the numbers and keep the sign of the larger absolute value. In our next example, we have 6 minus negative 6. So if I draw a line here, put the minus sign in the middle. When I do my keep, change, change, I'm going to keep the, sorry, that should be a 6. I'm going to keep this 6. This minus will change to plus, and the negative 6 is now a positive 6. So 6 plus 6 is going to give me 12. In my next example, I have negative 4. The minus sign is going to change to plus. And the 7 back here is going to change to a minus 7 or a negative 7. So now these are the same signs. They're both negative, so I'm going to add them together to get negative 11. The next example, we have a negative 9 in the front. The minus sign in the middle is going to change to a plus. And the negative 15 at the end changes to a positive 15. So now they're different. So I'm going to subtract the numbers, and I get 6, and my answer stays positive because there's more positives. And in my last example, I have 4 minus 16. So the 4 stays, minus goes to plus, and the 16 goes to a negative 16. Since they're different, we're going to subtracting it 12, and we're going to keep the negative sign because there's more negatives. And the last thing I want to point out when adding and subtracting is this right here. Your double negative makes a positive. So anytime you see these two negative signs together with no sign or number, in between, this is called a double negative, which goes to a positive. So you have a double negative right here and right here. So notice both times they became a positive. And sometimes you can just take the problem, when you see these two negatives together, you can just take it and just make them to a plus sign, just like that, right off the top. Make that go through there. Just take that and make it into a plus sign. And you already have your addition of the opposite. Okay, our last operations should now be on page 9. Is multiplying and dividing. And they're going to go together because they follow the same exact rules. This should be the easiest part of integers, is multiplying and dividing. And it says same signs, your answer is positive. Different signs, your answer is negative. Okay, you got two little diagrams that you can use to help you remember. But remember, these only work for multiplying and dividing, not adding and subtracting. Okay, the way the little triangle works, and I tend to write my triangle like this instead of turning it, the other way to where the plus is on top, because it kind of looks like a little face. Kind of cute, isn't it? Okay, but anyway, let's say we have this problem right here. We notice that the first number is a negative, so I will cover up the negative. The second number is positive, so I'm going to cover up this positive. So now it's telling me my answer should be negative because that's what's left. Okay. If I look at the second example, the first number is negative, so I'm going to cover up a negative. The second number is also negative, so I'm going to cover up another negative. And now what's left is positive, so that's telling me my answer should be a positive. And notice it is. So that's the way we use that. Now on your tic-tac-toe board, you do your tic-tac-toe board by doing plus signs in a diagonal and then just fill in minus signs everywhere else. And you can go any direction. This says a positive and a negative will make a negative. If you have a negative first and then a positive, you get a negative. If you have a negative and then a negative, you'll get a positive. If you have a positive and a positive, your answer is positive. I mean, you should know that. You've been doing it all your life. So any way you go, positive, negative is negative, negative and negative is positive, you're going to get, the correct solution. So we have these examples that I need you to copy down that follow our rules up here. The last thing I want to point out is when you get to this type of example, so when you have more than two numbers, you want to take two numbers at a time. So notice I took the -2 times the 3 first, and I got the -6. Then I brought down this -2. Now when I do -6 times -2, it gives me a +12. So just take two numbers at a time until you get to the end. It's just like order of operations. Okay, and these last couple of little statements just kind of explains anytime you have more than two numbers. If you have an even number of negative signs, your answer is always going to be positive. If you have an odd number of negative signs, your answer will always be negative. Because think about it. Let's say I were to add in another number here and it happens to be a negative. So even if I put in -1, if I bring this -1 down and multiply it by the 12, it's going to change my answer to a -12 because I would have 3 negative signs. So that's all that's saying. So just pay attention to that and you got it. Integers should be pretty simple.